I want to go over the empirical exercise 2, question 1 and 3, okay? And I want to show you a couple of things as we go through those questions. So, first of all, what are we trying to find out? In question 1, we simply want to interpret the scatter plot. Okay, so let's do a scatter plot of total expenditure and income. So I have on the y-axis expenditure, I have on the y-axis income. Do you see a pattern? Do you see that when income increases, whether total expenditure increases? It's not immediately obvious, okay? So because it's not immediately obvious, we might want to follow that up by running a regression on that. In this regression, let's look at the little bits of output that it's in the regression. I have made a more extensive video on this, but these bits here are your TSS, right? Sorry, ESS, right? This is your explained sum of square. This is your residual sum of square, okay? This is your total sum of square, okay? This bit here, the F-test, is testing the hypothesis, and we will see this later in the course, but it's testing the hypothesis that both these coefficients, the beta 1 and the beta 0, are simultaneously equal to 0. Okay? And this high value of the t-test is telling me that it's very unlikely for that to be the case. Okay? So I will reject the joint hypothesis that those two coefficients are equal to 0. This t-test here is for the individual hypothesis that says, I believe that beta 1 is equal to 0. The high t-value tells me that there is a statistical positive correlation between income now and expenditure. So if I asked you, let's think about Keynes. Keynes said that if you get any short-term income, like I give you some windfall type income, you will tend to consume more. So the animal spirit will take over you, okay, and you'll consume more. Does this output confirm Keynes? Does this output confirm Keynes? What do you think? I'm looking at this coefficient, seems to be positive and statistically significant. So income now is correlated indeed with more consumption. Does that support Keynes? Doesn't contradict it, but you got to be a bit more careful. Yeah.
It doesn't have to be significant. That's statistically significant.
It is statistically significant. So the question was, wouldn't it have to be statistically significant? And my answer is, yes, it is statistically significant. So does this support Keynes? The answer in econometrics often is very subtle. And the answer to this is not necessarily. Why? Because, let's think about this. Income here is not a windfall. It's not some income that came from the sky. It's your income, how much you are making. This income is probably correlated with how much you're going to make next year as well, right? So this income here, it's probably to do with your permanent income. Of course, if someone has more income, more permanent income, they're going to consume more. That's not supporting, per se, Keynes' hypothesis. So even though you see a positive and statistical relationship or correlationship between income now and consumption now, it does not mean that Keynes was right. We need some other better ways to try and figure that out. And that's where this paper is, that's what this empirical exercise is aiming to do, is coming up with a smart data set that allows you to distinguish between those two. Yeah, question. Question is, how do you determine if it's significant or not? You determine it by looking at this t-value or this p-value. If this p-value is less than the significance level, then we say that it is significant at that significance level. So for example, if I was doing at 1% significance level, this p-value is much smaller, right? So I reject the H0, that the underlying true parameter is equal to 0, okay? if you look at the video on the output of the regression, you'll get a little bit more intuition on this interpretation of regressions. We will do a lot of this over the course of the year. Okay, so you'll see a lot of these regressions being interpreted. So far, so good. Yeah. So that's question one. Let's go to question two. Now we want to plot happiness and income. What do you think? As you get more income, are you happier? Yeah.
Sure, but what about the R squared in the previous question?
Yeah, so the R square here, it's 2%. The R square really tells you how much of the variation in the Y, how much of the variation in the actual data is explained by the variation in the fitted values, in the Y fitted values. Generally, this R square, for me, it's not very important. I don't really tend to look much at the R square. This is because you could have a very small R square, right? But a statistically significant coefficient, and you might even have a very good regression, even with a very low R square. Okay? Why is that? Because that simply tells you that there's other things affecting expenditure beyond your income now. Okay? That's what it's telling you, right? There's a lot of other things, or a lot of other factors that are affecting your expenditure. Okay? So again, I touch upon this R square a little bit, but I don't lose sleep over a low R square. And I don't get excited when I get a very high R square. Okay? Holding everything else constant, of course, I'd like the R square to be higher, but I don't get super excited or super morose for getting a lower or a higher square. What do you think about this graph? Are you getting happier? Daniela, what do you think? To a certain point. Why is that? Where do you see? You can kind of see, like, as your income is going up. This seems to be kind of going up here, right? Seems to be going up this way. So to a certain point, it seems like, even though it's not immediately clear, it seems like there should be a positive correlation there. Let's try to see if we can establish there by running a regression. So if we run a regression, what do we notice? What do we notice if we run a regression? Well, we notice that this coefficient is positive, and we notice that it has a very high p-statistic, right? So, and the p-value is very small, which means that I believe that there is a positive statistical significance of income now on level of happiness. Right? These things are positively correlated with one another. Okay, that's what I have at this. That's what I have at this moment. Yeah, Danielle. That's the question is, how can you tell that it's positive? Just look at this coefficient here. Okay, this is positive. Look at the sign of this. Okay, how could I tell that it's statistically significant? Look at the t-value. Any t-value of greater than 2 or minus 2 will generally tell you that that is statistically significant at a 5% significance level. Yeah.
Does that depend on how many observations you make?
The question is, does that depend on how many observations you make? The answer is no. You could have millions of observations, and you could have a t-test that's very close to 0. You could have very few observations, and you could have a t-test that's very high. The value of the t-test here will depend on the strength of the correlation or covariance between the y variable, happy now, and the x variable, income now. Okay, that's what it would depend on. Yeah.
So even though the correlation is very, very small, because the t-test is high, it's still statistically significant.
Yes. So the question is, even though this correlation, which we shouldn't really call it correlation, we should really call this the estimated coefficient, right? This estimated coefficient is very, very low. Because the t-test is very high, statistically significant. Why is this happening? Well, this is happening because, look at the scale here. Happiness is being measured from 0 to 10. Income is being measured from 0 to 200,000. Okay? So how do I interpret this bit here? Is I say, an extra dollar is changing my reported level of happiness by 0.00002. But it's statistically significant, okay? But it is statistically significant. Yeah, Daniela.
So even if the estimated coefficient is high or small, it all depends on the t value
Absolutely.
being high or too low.
Absolutely. So the comment/question is that it doesn't really matter what this value is in absolute value, like how big or small this is, right? You should always focus on the t value to determine significance, okay? Always look at that, because look guys, if I change, and we will see this later on, but let's say I generate a new variable. Let's call this income test, and let's say that this income, I want to express this in thousands. So I go to income now, and I divide this by 1,000. Can I do that? I can express income in thousands of euros, right? Can I express it in 10,000s of euros? Of course I can. Okay, I can express it in 10,000s of euros. So let me try and run the same regression. Happy now, and income test. All of a sudden, I'm getting a much bigger coefficient. Okay, because the interpretation is changing. But look, is the t statistic changing? No. So by scaling those coefficients, of course I can make this coefficient as little or as big as I want. Doesn't tell me anything. So by scaling my data, I can scale that coefficient as well. But the significance doesn't change.
So is it not the correlation coefficient, or it is? Because like, isn't correlation coefficient between -1 and 1? So wouldn't it not really change even?
So the question is this a correlation coefficient? The answer is no. Okay. This coefficient here, as you will see very soon, if you haven't seen yet on the lecture, is equal to the covariance between happy now and income divided by the variance of income. Okay? But as I change the units of the income, the variance of the income also changes. Okay? So it also changes that number. This number can be like 3,000 or minus 3,000, okay? So it's not a correlation coefficient that sits between 0 and 1, okay? As you will see in the course as well. Keep those questions coming, okay? As you see things that are not making sense, or you want to make a comment, or you want to reassure yourself about something, keep those questions coming. So far, so good. Now, we haven't quite described, can we then say that more income makes you happier? Does this provide us some evidence to say that income causes you, we know it's correlated, but does it cause you to be happier? Does it cause you to be happier? Yeah.
We could never answer the question, right? Because we just look at correlation.
Yeah, so basically this is a bit of correlation, doesn't necessarily imply causation, right? But we want to follow that up with an explanation that might help us see why correlation might not necessarily imply causation. Right? Here's one way that you can think about it, is reverse causality. Okay? Could it be that happier people are more productive and hence earn more? Could be. Could be that higher level of happiness make you more productive, right? And hence you earn more. So it's not that the higher income was making you happy, it was because you were a happy person that you were earning more. That's one channel that you can think of. Here's another channel you can think of. If you are sick, what's likely to be your level of happiness? Low, right? If you are sick, how likely are you to be productive in terms of to have a high income? You're likely to have a low income. So all of a sudden, sickness is causing your lower level of happiness, and it's also causing your lower level of income, and you're only focusing on the correlation between income and happiness that had nothing to do with one another. Okay? But the sickness was the one that was influencing both the happiness and the income. Can you see that channel? Right. So when Daniela was right at pointing out correlation doesn't mean causation, but if you're writing that on an exam, you want to follow that up with an explanation. why does this correlation not necessarily imply causation? Can you give me an example or a channel where the correlation is not due to causation? And some answers that you could do here, you can think about reverse causality. You can think about a third variable like sickness affecting both of these variables. Okay. Those will help you kind of frame your answers. So you don't just say correlation doesn't mean causation and you stop there. Okay. But you think a little bit harder about why that's the case. Right. Okay. So let's go to question 3. So, of course, the main challenge of an empirical work is the inability to obtain a valid counterfactual. A valid counterfactual is what? Is two groups of people which are identical, but with one exception, on the treatment effect, whatever the treatment was. You gave someone extra income. Okay? That's why this lottery data set is actually quite powerful. And by the way, all these empirical exercises come from exceptionally well reputed journals. Okay, so these authors published this paper at the American Economic Review, which is one of the top 5 journals in the world for economics. Okay, so if you were interested, you could take their paper and you could read their paper and you could see what kind of work they did, and you can get a sense of, one, how good consultancy work should look like, or how good academic work should look like. And you might come to realize that, oh, if I had this data, perhaps I could do this as well. Right? And you can get a sense of like what is top work looking like. Most of the empirical exercises we look at rely on some smart data collection, right? This was a smart data collection because it relied on randomness of lottery winnings, okay? And that's why it was a smart data collection. So if I want to focus on finding valid counterfactual, question 3 asks us to test whether buyers and non-buyers have similar characteristics in terms of consumption and happiness before the outcome of the lottery. Okay, so what we're trying to do is we're going to run a t-test of the total consumption before by buyer. Let's do this. Let's interpret this t-test, okay? So a common question that says, what's this output of the t-test? What does it tell us? I've done a video already for this, but it doesn't hurt to review. What is this telling us? How many individuals do I have in this data set? How many individuals do I have in this data set? Very good. We have 1,302 individuals, okay? That are either buyer or non-buyer, okay? How many of them bought a lottery ticket? 384. So not everybody buys, and a smaller proportion of the population buys lottery ticket, okay? So you might start to wonder, is there something different about people that buy lottery tickets and people that don't buy lottery tickets, right? Because those are important questions. So for example, one of the class teachers here in the management department, Vincent Hotyat, used to be the vice president of the Eurolotos, right? So he ran the whole operation of Eurolotto in Europe. And one of the things that he said is that we had huge penetration rates on poorer areas than we did on richer areas, okay? So rich people tend to not buy lotteries, okay? For example. So we want to really exploit this idea of, are these two groups different, right? Even before winning or not winning, okay? So let's look at their expenditure. This was the expenditure of the people who didn't buy lottery. This was the expenditure of people that did buy lottery. This was the standard deviation, or the standard error that you kind of measured, or actually standard deviation right here. And this is the confidence interval that you have. But really what we're interested on is this difference between these means. And we want to know the test statistic associated with that difference. How do I find this test statistic associated with this difference? Well, it's the difference that I had divided by the standard error of the difference. And of course, you can review your ST107 notes to kind of see that precisely why that is. But we get a relatively small test statistic. So any test statistic that is less than 1 would be relatively small. Yes? Can you ask that question one more time?
What is the mean time?
What does this tell us?
Yeah.
This just tells us the average expenditure of the people who didn't buy lotteries. So this thing here is the group, the people that didn't buy lotteries. I collect all of those people. I just do a simple average of how much they were spending. And that's what that mean tells me. Does that make sense? Yeah? Okay, good. And this test statistic is relatively small, okay? So the null hypothesis says that these two means are the same. If these two means are the same, this is the same thing as saying the difference is equal to 0. Okay? And then I say, okay, what if I have the alternative hypothesis that this difference is less than 0? What's the associated p-value with that? Is 19.20. Let's try and visualize this. Let's try and visualize this here. So what I have is I draw a t distribution that looks like a normal distribution. So the way I go about drawing it here is I think of a bell-shaped normal distribution. And then I take this value here, minus 0.87, minus 0.87, and I put it in there. And that's the value of my t. Okay? And this is the PDF of capital T. Let's call it capital T for the random variable. So when I look at this bit here, it's telling me what's the probability that I'm going to observe a t, capital T, the random variable, that it's lower than my little t, which is what I found here. Okay, so effectively we're being asked, what's the probability of being to the left of this? The probability of being to the left of this is, well, we have been given it from it's 0.1920. Let's check this out. What is this telling me? What's the probability of being to the right of it? So it will have to be probability of being to the right of it would be this. What do you think should the sum of this number here with this number here be? 1, of course. Always. What do you think this number here and its relationship with this number here should be? What should be the relationship of this number here with this number here? Doubles if the t statistic was negative. What if the t statistic was positive? This thing here would have been the double of this side here. Okay. So if I go here, right, where do I find the p-value of the two-sided test? I replicate the exact symmetric point here, which is 0.87, and then the p-value associated with that hypothesis will have to be this plus this. So this is 2 times 0.1920 if I add these two together. Okay, so what does this test tell me in English? In English, this test tells me that it seems like these groups of buyers of lotteries and non-buyers of lotteries did not differ in their spending pattern. Okay, at least at even a 10% significance level, right? Okay, let's look at the next one. Let's try and do the same thing, but for happiness. Aha. Well, look at the difference here. They look like they're relatively small, but really what we should focus on is we should focus on the t-test associated with this. The t-test is approaching an absolute value of 2. Okay? So that should be indication that, you will probably reject the null hypothesis at least one of these settings. And indeed, we believe that the people who did buy the lottery are, even at a 5% significance level, we believe those people to be happier. So for whatever reason, people who buy lotteries are happier. So there is some difference in those two groups already existing. Okay? And if I go back to here, we just did this. We tested whether buyers and non-buyers are similar characteristics in terms of consumption and happiness before the outcome. In English, we concluded that while their consumption pattern seems to be similar, their happiness seems to be statistically different. Okay. That's the question is, why is that the case? Well, that's what the data tells us, right? How did I see that information on the data? I just interpreted this t-test, right? Here I have a very high t-test, and it was negative. So that gave me confidence. That this difference here, which is negative, is statistically significant. So I can say that these two levels are different. This bit here was a small t statistic, so that took away confidence from me that these two are different from one another. Okay? So in short, it was this high level of the test statistic here that kind of gave me some confidence on it. If I were to kind of show you this on a graph, remind me your name? Jaime, that's right. So, Jaime, if you look about this graph here, right, this test statistic here, 0.87, it's relatively very close to this 0, okay? So if the null hypothesis is true, it is possible that I could have gotten a t-statistic of 0.87, okay? But if the null hypothesis is true, and I get something like 6.01, okay, then I say, well, look, actually, it's possible that I could have gotten 6.01, but it's very unlikely. So then now I say, well, I'm not believing that this is true, okay? So what's happening here is that you're having this fairly high t-statistic, and you're saying things like, oh, I cleared it. You're saying things like, how likely is it that I'm going to observe even more extreme values, right? And it's, very unlikely. So that t-test is the t-test statistic is very extreme, okay? So on one hand, you're rejecting it, on the other, you're not rejecting it, okay? Keep those questions coming, okay? Even if you think I just explained it, I want you to kind of keep those questions coming, yeah?
Do we have to find a balance between interpreting like the t-value and the p-value? Just like, if you look at the p-value, you'd say that because it's like, say, greater than 0.15,
yes,
it's not significant.
Right, yes, correct, yes. So you have to kind of strike a balance between those two, right? So that's what I do. I usually take a 5% or a 1% or whatever, okay? But you don't have to. You could just report the p-value and you'll be clear, right? It would be clear. The p-value of 3% means that at a significance level of 5, you will reject the H naught in favor of the H alternative, okay? Here, you will not reject the H naught in favor of the alternative, right? You would say, I'd rather stick with the means being the same rather than say that the people who don't buy lottery are happier, okay? Yeah, Daniela. What were the difference in the commands between the two tables? Nothing but, the only thing that I'm changing is the variable that I want to test on. So here I'm testing the differences in the happiness level, and here I'm testing the differences in the consumption level. So I'm looking at different variables, okay? This was consumption, that was happiness, yeah.
Do we always anchor like the significance level of like 0.05, or how do we know necessarily when
No, you don't have to. You can pick whatever you like, right? So for example, let's say for example, that's a good question. So the question is, do I have to take a 5% significance level? I've done a video for this, but if this was 0.07, what should you do? I would say the p-value associated with that test is 7%. Let the reader decide what they want to do. So at a 5% significance level, you will fail to reject. At a 10% significance level, you would reject the H0. Okay? So don't be too obsessed about the significance level, okay? Just focus on the p-value. That gives you a lot more information, right? It tells you when you will reject and when you will not reject, okay? So if you look at this do file, what Jordi gives you, it says, well, actually, I don't have to stop at just checking expenditure and happiness. I could check all sorts of things. Vacation spending, durable spending, transport spending, all sorts of things, right? And I could see whether these two groups are similar or different by looking at all these characteristics. And that's something that you will do. Because remember, the goal is to find valid counterfactual. So if you're going to compare buyers with non-buyers, if there's some inherent differences between them, then your case is going to be a lot weaker. Okay? So I will stop this thing here.